was in. Good morning. Rose. Settle. अच्छा जी.
मैम वॉल्यूम 1 एंड
Okay. So let's start with the new topic in thermodynamics, that is heat, internal energy, and work. We'll separately see what internal energy is, what do we mean by internal energy, how do we change it, what is exactly heat, what is work in thermodynamics point of view. And we'll see some thermodynamic system and thermodynamic process. Let's start page number 77 it is. So we know that every system means you can consider any system, either it is macroscopic, microscopic, small, large, anything. That a cup of tea can be a system, the whole class can be a system. So every system consists of large number of molecules, and for that molecules, the internal energy can be defined as the energy associated with the random disordered motion of the molecules of a system. So any system consists of n number of molecules, particles, or we can say in standard terms molecules. So internal energy is that energy of the molecules which are very randomly moving. Okay? Or its motion is disordered. Its motion is not following any particular path. म्हणून आपण mean free path calculate करत होतो ना KTG मध्ये. Because we have considered there the kinetic theory of gases. Here also we are considering system which consists of n number of molecules, and internal energy will be nothing but the energy that is associated or related with that randomly disordered motion performing molecules. Internal energy definition समजली? It is the energy associated with random disordered motion molecules, disordered motion of the molecules of the system. Okay. So it is different than the macroscopic ordered energy of moving object. So we are not considering here macroscopic things. We will go into detail of the microscopic. For example, a glass of water kept on table has no kinetic energy because the whole glass is not moving. But we know from kinetic theory of gases that water molecules in the glass at given temperature, they always try to move with a random speed and in random directions also. So we can say that internal energy of substance is total energy of all of its atoms or molecules inside it. So the whole glass is not moving, so it is not having any kinetic energy, but water molecules inside that glass, very little molecules having n number of molecules we can say, those are continuously moving with the random speed and random directions. So that molecules possess some amount of energy. Okay, internal energy macroscopic total glass of water से नहीं बहता है, water molecules. Okay. So we can say that internal energy of a system is the total energy of its atoms. So for ideal monoatomic gas, mono you know, single atomic gases. And ideal means it is having ideal gas equation. So for monoatomic ideal gas, internal energy is just translational kinetic energy of the atoms having a linear motion, which we have already discussed. And for polyatomic gas such as carbon dioxide, we consider rotation and also vibrational kinetic energy of molecule in addition to the translation. You know this words well. In case of liquids and solids, this was the case of the gas. For monoatomic, it is moving in only one direction. So the energy will be only associated with the translational motion. while in die it will be translational plus rotation, and for poly it will be translational plus rotational plus vibration. All these will contribute to the total energy of the atoms. This is the case of the gases. In case of liquids or solids, we need to consider the potential energy of the molecules due to intermolecular attractive forces among them. So molecules and molecules also exhibit some amount of forces. We have to take this forces into account. Remember, this is again at molecular level, that is microscopic scale only, and internal energy of the system is denoted by capital B. Okay? It is always denoted by capital B. Potential energy will also so capital U in thermodynamics is internal energy. Internal energy is microscopic basis what we find out also macroscopic. It will always related with the molecules and atoms, not the whole substance. Okay? In the internal energy रूमची काढायची आहे तर मोठ्या मोठ्या ऑब्जेक्ट्सचीच नाही inside molecules number of molecules ची internal energy मिळतात. Now the next topic is thermodynamic systems and thermodynamic process. Thermodynamic system and thermodynamic process. So let's understand what is exactly this thermodynamic system and thermodynamic process first, because the next terms is heat, work, change in internal energy will be totally associated with these two terms. मी खूप वेळा म्हणणार आहे this is thermodynamic system, this is thermodynamic process. So all that processes isobaric, isoporic, isothermal, adiabatic, etc. are nothing but thermodynamic. So thermodynamic system is nothing but the collection or group of objects that can form a unit which may have ability to exchange energy with its surrounding. It may have, it can have, it cannot. Okay? So thermodynamic system is nothing but the collection or group of number of objects it can be. And these objects can form a single unit whose study we have to do, and the single unit can exchange energy with its surrounding. So suppose this room is a thermodynamic system. It can exchange heat or energy with that surrounding. Surrounding is everything outside the system in universe. Samajhte? So suppose this bottle is a system, rest of the universe including this classroom is its surrounding. If class is the system, rest of the thing is in surrounding. Okay? If PCMC the whole is a system, rest of the things in the universe other than the whole area of the PCMC is used. So surrounding is everything in the universe except the system. Okay? So thermodynamic system means it is a group or collection of the objects and forming a one unit which we have to study, and it may exchange energy with each other. Anything that is not part of the system is its surrounding or its environment. Environment, surrounding is nothing but the same, but mostly we will use the word surrounding. Everything in the universe present except the system. Okay? That is your surrounding. So for example, मी आता ते सांगत होते तुम्हाला, water kept in a vessel, its system. The vessel is its boundary and the atmosphere around it is its surrounding, and it is shown there. काही गरज नाही तुम्हाला ते दाखवायची. Simple. This water is a system. Okay? Water inside the bottle hole is a system. This bottle is its separate करतोय ना system आणि surrounding ला, त्याला काय म्हणतो आपण boundary, and outside the whole surrounding. So boundary is the thing which separates the system and the surrounding. Okay? Boundary माहित असेल ना. Thermodynamic systems can be classified on the basic basis of possible of heat and matter to environment. So based on this, heat or matter exchange करतोय नाही करतोय. So based on this, there are types of thermodynamic systems. Based on this, they can be classified in three types. It is open, closed, and isolated. So based on the heat and the matter, thermodynamic systems can be classified as open system, closed system, isolated system. So what is this open system? An open system is a system that freely allows exchange of both energy and matter with its surrounding. Examples are given and example म्हणून खूप व्यवस्थित लक्षात राहतात. Words पण simple आहेत, काही difficult असं काही. So if your system is open system, then it can exchange both energy and matter. Heat म्हणतो आपण, but heat is a type of energy, so we will generalize this system as the system who can exchange both energy and matter with its surrounding is your open system. Example is water boiling in a kettle is an open system, so heat escapes into the air and this is the exchange of energy with its surrounding. But at the same time, steam also escapes into air, so this is exchange of matter with the surrounding. So if water is boiling, that heat vapors, heat basically heat exchange होते means बाहेरच्या साईडला पण गरम होतं ते आपल्याला outside surface. So it is exchanging the energy. It's outside boundary outside is accepting its heat. So it is exchanging heat. And second thing, evaporate होते, evaporate नहीं normal. Vapors येतात बाहेर. Vapor is nothing but the water, but in different formats. So water boiling in any vessel is your open system. It is able to exchange energy, that is heat, and at the same time matter, that is water, with its surrounding. Clear? जर विचारलं classification of thermodynamic systems, processes नाही हा, processes वेगळे, systems वेगळे. Systems वेगळे. So based on this energy and matter, classification is open, closed, isolated. क्लासिफिकेशन आलं तर ब्रीफ मध्ये एक्सप्लेन करायचं, छान एक्सप्लेन करा, मार्क्स देऊन टाकू. Example and definition is important. Second is closed system on the other hand does not allow exchange of matter but allows the transfer of energy. So in second case, that is the case of closed system, it can exchange only energy. We exchange वाला कुछ both. Example is water boiling in a boiler is closed system. It allows only heat or energy to be transferred from source of heat burner to the water, and similarly heat is also transferred to surrounding, but steam is not allowed to escape as long as valve is kept. काही नाही, अंघोळीचं पाणी त्याच्यावरती टाकायचं, थोडं सिंपल. ठीक आहे. वेपर्स एस्केप नाही होऊन द्यायचे, हीट एस्केप होऊन द्यायचे. सो एक्झाम्पल इज दिस वॉटर बॉइलिंग इन अ बॉयलर. बॉयलरला वाल्व असतो टू एस्केप द हीट, तो वाल्व क्लोज ठेवायचा. दॅट विल बी युअर क्लोज सिस्टम. सो इवन दो इट इज क्लोज फ्रॉम आउटसाइड इट गेट्स heated. ठीक है. So here the energy, that is heat, is exchanging, but matter is not exchanging. Third is isolated. So isolated system is completely sealed. That is isolate the meaning माहिती ना, to get separate. Be separate. So matter as well as heat cannot be exchanged with its environment, and a thermos flask is very familiar example of an isolated system. किती पण गरम किंवा थंड पाणी ठेवा, बाहेरून पण ते गरम नाही होत. It will neither exchange heat or energy nor the matter. So isolate मध्ये isolated system, no exchange of any energies. वर्ड्स वरतून पण होतं. ओपन इज सगळं एक्सचेंज करायचं, क्लोज इज एनर्जी फक्त एक्सचेंज होते, आणि आयसोलेटेड नथिंग इज एक्सचेंज बिटवीन सिस्टम अँड द सराउंडिंग. सिस्टम समजला आता काय असतं, ग्रुप और कलेक्शन ऑफ ऑब्जेक्ट, इट विल फॉर्म ए वन युनिट that we have studied. And surrounding is everything in the universe except the system, and boundary is the thing which separates the system from itself. And diagram is showing you open system, closed system, and isolated system. The what else करायचं? First case मध्ये असं दाखवायचे वेपर्स, सेकंड केस मध्ये वेपर्स दाखवायचे पण क्लोज दाखवायचं, लीड लावलं. काढलेत वाटतं डायग्राम्स एकदम. आणि थर्ड मध्ये नो एक्सचेंज ऑफ एनर्जी. काही डाऊट आहे? मानसीला डाऊट. So next is a thermodynamic process is a process in which thermodynamic state of a system is changed. State is position of the system at any instant. आता जे प्रेझेंट आहे त्याचं प्रेशर व्हॉल्यूम टेम्परेचर ती त्याची एक पर्टिक्युलर स्टेट झाली. ठीक आहे. जसं आपण स्टेट्स ऑफ मॅटर म्हणतो, स्टेट ऑफ मॅटर सॉलिड लिक्विड गॅस. सो इट इज कन्वर्टिंग फ्रॉम सॉलिड टू लिक्विड. इट इज अ प्रोसेस फॉर द कन्वर्जन ऑफ ए स्टेट समजलं. So for example, water contained in a vessel with a lid on it is open system. When the pot is heated externally, water starts boiling after some time and steam is produced which exerts pressure on the walls of the vessel. So in this case, state of the water in the container is changed. Initially the water is in the vessel only and it is closed with its lid. Okay. After some time, gas चालू आहे. It starts boiling. So during this whole process, its pressure is changing, volume is changing, temperature is changing. Volume पण change होतो. जर त्याची steam form होती तर water कमी होतं. So the state of the whole process is changing. Thermodynamic system ची state change होती आहे आणि state change होण्याच्या त्या पूर्ण movement ला आपण म्हणतो thermodynamics. So this is because temperature T, volume V and pressure P of the water inside the vessel change when it starts to boil, and so we can describe the state of the system by using temperature, pressure and volume as variables. And we'll obviously discuss this in detail in next sections. So what is this variables? जसं आपण 2 dimension मध्ये सांगतो. Degrees of freedom, the minimum number of parameters which are needed to describe the whole system. As here we are considering system as a as a gas in a closed container. So in order to describe the whole state or the position of the gas at any instant, you will need to know its pressure, volume and temperature. These are the minimum amount ki baba ह्याच्याने पूर्ण gas describe होऊ शकतो. And if the process is the boiling and after some time its P, V, T all three will change. So as its parameters, or here we'll particularly say the state variables, P, V, T, state variables are changing. So the whole process is thermodynamic process. It is related with it. Clear है? कोई doubt है? Thermodynamic system, thermodynamic process. Process with the state variables change. Next is this heat. We are done with internal energy. Then process and systems. Now we'll move to the heat. Heat बघायची आणि heat समजल्यावरती change in internal energy समजतो. काही वाटतंय? heat समजतं? रणवीर? Okay. The next topic is heat. Let's now try to understand heat and also its relation with the internal energy of the system. As we have already discussed about the internal energy, we will see the new topic heat and the relation between these two. So consider a glass. Examples असे सगळे दिलेले आहेत जे तुम्ही करू शकता. जसं आज मी बघितलं चेक केलं काल मी सांगितलं टेम्परेचर हां त्यांनी बॉइलिंग ऑफ वॉटर ऑब्झर्व केले व्हिडिओ पण काढला. सो याच्यामध्ये हीट इंटरनल एनर्जी सिस्टीम प्रोसेसेस या सगळ्या कॉन्सेप्ट समजण्यासाठी जे एक्झाम्पल्स दिले ते खरंच खूप रिअल लाईफ आहेत. तुम्ही करून बघू शकता. असं नाही की कोणतरी सांगितलं. Now consider a glass filled with water on a table. The glass along with the water in it forms the whole system. Glass is also the part of the system and water inside it. Let the temperature of the system be Ts. Ts stands for temperature of system. The table on which the glass is kept and the other relevant parts of the room will then be its surrounding or the environment. सध्या आपलं एवढंच युनिवर्स. ठीक आहे? आणि macro. So this is our system. The whole is system along with the water, and there are so many objects present over here. All this except this is just our environment: benches, walls, fan, light, you, all made up of molecules. Let the temperature of the environment be TE. System's temperature TS, environment's temperature TE. We notice that if Ts and Te are not the same, then Ts will change until both the temperatures are equal and the thermal equilibrium will be reached between the system and the environment. थोडासा जरी गरम पाणी असतं थोडा वेळ ठेवलं तर it will get cool, and if it is so cool it will get to the normal गरम नाही, it will get to the normal. ठीक आहे. This will try to be at the temperature with the surrounding. They'll exchange something. Something is nothing but the heat. So they'll exchange heat until and unless they both are, who both system and the environment here, surrounding here. Surroundings as nahi वापरला है same same. So until and unless they both are at thermal equilibrium with each other. Now TE will also change to some extent, but the end result is that system and environment will reach the equilibrium. किती पण उकळतं पाणी आणून ठेवा. Obviously this will try to accept the energy from it, but at the end both are at same temperatures. So if environment is very large, change in TE may not be measurable, but certainly is not zero. Means if this is so much as compared to our system, change in the temperature of the environment is not measurable quantity. But change zero पर नसतो, there can be a slight change in the temperature of the environment. So such a change in temperature here is caused by transfer of internal energy at a heat knife. So this is due to the transfer of internal energy between the system and its surrounding or environment, and in this case transfer of energy is between the glass of water and our classroom. So this is about the heat. Now we will consider a system, rigid system, shape system and environment. We'll see the positive, negative काय काय असते. Page number 79, the diagrams. Energy flow into the system, out of the system, etc. etc. So first case, suppose 4.48 is. It shows energy transfer between system and its environment. So let Ts and Te be the temperature of the system and environment respectively, and we will consider the amount of heat as a capital Q. That is the energy transferred between the system and the surrounding. So in first case, if Ts is less than Te, consider three cases. Ts is less than Te. This is my system. System environment. ठीक आहे. कोणाचं टेम्परेचर जास्त आहे एन्व्हायरमेंटचं. मग कोण हीट ऍक्सेप्ट करेल आणि कोण हीट यूज करेल. Heat is accepted by system. So heat flow is like this. Okay, and here Q is greater than 0%. Okay, so environment is T, system T is temperature. Q is heat or energy. Heat energy, generalized energy. So here for surrounding, Q is greater than 0. Second case, if Ts is greater than Te, again my system. Okay. Temperature कोणाचं जास्त आहे सिस्टमचा? It will give heat to surrounding. So now in this case for surrounding, Q is less than 0. ठीक है. Energy transfer अशी किती energy transfer करणार आहे? खूप small amount करायचं. ठीक है. And in third case, if both are same, Ts is equal to Te, No energy flow between these two because दोन्ही same आहे. So Q is equal to 0. Means याची जी heat change होणार असेल, energy accept lose होणार असेल, that is equal to 0. So there is no transfer of energy. Q is your energy transfer. Huh? Here energy transfer is greater than 0 when system accepts. त्याला पण हेच बघत होतं ना, work done energy. When system accepts heat, it is positive. म्हणजे आपण प्रायोरिटी कोणाला देतो? सराउंडिंगला देतो. सराउंडिंग सिस्टम. System accepts heat greater than 0. System loses heat less than 0. And no exchange Q is equal to 0. नाही लक्षात? शॉर्ट मध्ये लक्षात ठेवायचं. System accepting heat Q greater than 0. Losing less than 0. No exchange equal to 0. this त्यांनी डिस्क्राइब करून दिलं. छोटे छोटे डायग्राम्स काढून नोट्स मध्ये. Now next topic, very important it is change in internal energy of a system. Means we have already seen what is internal energy. Heat आणि internal energy चं रिलेशन पण पाहिलं आपण. ठीक आहे की temperature change is because of the transfer of the internal energy. That is energy of those molecules ना. Heat पेक्षा particularly means internal energy of that molecules is exchange to change the temperature or in order to attain the thermal equilibrium condition. Next is change in internal energy of a system. So any system, here obviously gas enclosed in a container, we wish to change its internal energy by number of ways are possibility is number of ways we have. So we'll see the two ways here. Now in previous discussion, we have seen that internal energy of a system can be changed. It can be gained or lost. Change means you can increase or decrease due to exchange with its environment. Surrounding is there. If it is free, that is open system, it will exchange. Okay. Now we'll try to understand how exactly this transfer of energy between system and surrounding is possible. So we have two experiments here. Let's consider the first one. The diagram first, it's showing you a cylinder filled with some gas in it. And the cylinder is provided with a movable, massless and frictionless piston at the other end. The piston लिहिताना तीन words लिहिणं खूप important. It is movable, you can move it. It is massless, means when you have to consider the mass of the system, piston's mass नाही. And frictionless means no friction, you can easily move. Cannot slide, but you can easily move. Okay. So it is movable, massless and frictionless. The gas inside the cylinder is our system and the rest is its environment. So let the temperature of the gas is system no. So temperature be Ts and for environment temperature be T. The internal energy of the system, that is gas, can be changed in two different ways. In either by one way, first way, either by second, or you can apply both the ways at the same time. It's quite complicated, but still you can find out how the internal energy is changing. So first way is change in internal energy of a system can be brought about by heating the system. So heat energy is supplied using. Okay, cylinder जो आहे ना तोडवा ठेवलेला. Initially it is at 100 degrees Celsius. If burner is there, it will reach the stage of 200 degrees Celsius. Diagram मध्ये असंच काही changes आहेत because piston move like this. So change in internal energy. So first case we have if this is the cylinder, त्याचं जास्त झालं आहे.
And ते थोडं फ्रिक्शन होते जरा साइड.
आपण कन्सिडर करतो आयडियल फ्रिक्शनलेस. This is अडवा cylinder having gas molecules in it आणि तो बोल्ट केलेला पिस्टन आहे. मला तुम्ही समजून घ्यायचं. ठीक आहे. तर मला जी इंटरनल एनर्जी चेंज करायचा फर्स्ट वे आहे. I have to supply the heat to it. मग ही फर्स्ट डायग्राम आहे and then सेकंड केस मध्ये सेमच येतो. So temperature initially 100 degrees Celsius, here it is 200 degrees Celsius. Exactly same. Motion नाही दाखवू शकत ना. So first case, the cylinder can be brought in contact with a source of heat such as a burner. So burner वाटतं ना? As discussed previously, the temperature difference between the source of heat and the system will cause the flow of energy, here the heat, towards the gas in the cylinder. Temperature of cylinder is 100. Temperature of burner किती असू शकतो? Around 250, 300, 300, 400. So in first case, इथं काहीच नाही, कोणी नाहीये त्याला heat द्यायला. In second case, cylinder and burner are in contact with each other. आहे ते contact. ठीक आहे? Its temperature was initially 100. Now its temperature is quite 300, 400, maybe greater than it. So now, as the temperature difference is there, there will be flow of heat. कुठला केस असेल यातला? Yes. TE is greater than TS. That is, system will accept the energy. Q is greater than 0. Right? This is no our case. So here TE is greater than TS in this case. And so there will be an increase in the internal energy of the gas. And such exchange of energy is possible in another way also. If surrounding is at temperature lower than the gas, Ts greater than Te, the gas will lose energy to its environment. हा फर्स्ट केस झाला. ह्या बर्नरच्या इथं मी आईस क्यूब्स ठेवले आणि मग त्याच्यावर सिलेंडर ठेवला, तर होऊ शकतं ना तसं. इन सेकंड केस Ts is greater than Te. सिलेंडरचा 100 डिग्री सेल्सिअस आईस क्यूब्सचा कमी असतो, और कोल्ड वॉटर मध्ये हा सिलेंडर ठेवला. ठीक आहे, इट्स अ सरफेस. सो द केस इज Ts greater than Te. Heat will exchange from system to the surrounding.
बर्नर हीट करते असल्यावर तेव्हा त्याचा 100 डिग्री सेल्सिअस असला ते इन्क्रीज होणार ना, मग ते एक्सचेंज करायला.
त्यांनी काय केलंय, अच्छा त्यांनी असं दाखवलंय बर्नर लावल्यावर आधी 100 होता मग 200. मी असं दाखवलंय दिस इज इनिशियल स्टेट आणि बर्नर लावल्यावर दिस इज फायनल स्टेट. सो माझं समजून म्हणायचं, तू बरोबर म्हणते खाली बर्नर आहे आधी सिलेंडर असा होता मग त्याचा एक्सचेंज वरच्यामध्ये झाला, माझा असा डिफरंट दॅन. Okay, so this change in internal energy can be in another way also, but same but different. Okay, so if ice cubes or cold water is here, it will be the second case. So now internal energy or heat is accept from system to surrounding or by surrounding. So heat is exchanging from system to the surrounding. So now Q is less than 0. Transfer of energy of the heat. Then the cylinder will become cool. Okay, let it be. Now the second way, this was the first way that will supply the heat to the system. Second is the other way to increase the internal energy of the gas is to quickly push the piston inside the cylinder so that the gas is compressed and shown. So in this case, what is changed? We have three parameters. So in this case, or in the first case, P is constant throughout, V constant throughout, E is going to be changed. In second case, what will we do? Burner ठेवून टाकायचा बाजूला. Now we have cylinder and this piston, we will move this piston inside the cylinder very quickly. It's काढून कलर कसं मारतात, पाणी मारतात तसंच आहे. ठीक आहे. So it will be so quickly that is given in your diagram 4.5. ठीक आहे, काढू का? दिस इज इनिशियल स्टेट, दिस इज फायनल स्टेट. पिस्टन इथे होता, त्याचा मूवमेंट या डायरेक्शन मध्ये गेला, इनसाइड सर्क्युलर. ठीक आहे, आउटसाइड. So in this case, we know that piston does some work on the gas in moving it through some distance. काम कौन करता है actually आपण करतो, पण gas वरती काम is doing this piston. Piston is moved inside the gas, so it is doing some work on the gas. Gas is a system, and piston is somewhat the surrounding. So now the surrounding is doing the work on the system. So in this case, the gas gains energy and its temperature is increased. On the other hand, if gas pushes the piston out, gas expands, work is done by gas, it loses energy and gas goes down. It is not as much as this 100 degrees Celsius temperature change होना. But when we try to push the piston inside the gas, it will get pressurized. Right? We have to P. Pressure will change, obviously it will change. Volume, yes, it will change. ठीक आहे, कारण हे सेम अमाउंट आहे तुमचा एरिया, पण इथे कमी झाला नाही याच्यापेक्षा. And the molecules are the same, so they get pressurized. Density is increased or decreased. Increase or energy, and temperature will slightly change because these molecules, as they are getting pressurized, it will gain some energy. They get energized. They will move rapidly and randomly than the initial case. So its temperature will increase. If the same but the opposite thing happens, if we try to push the piston outside, we'll try to pull the piston. Okay? So piston is moved outside the cylinder. It will get volume expanded. Expand झालं तर pressure कमी होईल, right? Volume is increasing, so hence temperature will decrease and gas will come. So these are the two, at the same time, four ways to change internal energy. Basically, two ways: by supplying heat to it and by doing some amount of work on the system. ठीक आहे. फर्स्ट केस मध्ये हीट सप्लाय केली तर इंटरनल एनर्जी इनक्रीज, हीट काढून घेतली तर इंटरनल एनर्जी डिक्रीज. पिस्टन पुश केला इनसाइड तर इंटरनल एनर्जी इनक्रीज, पिस्टन पुल केला आउटसाइड तर इंटरनल एनर्जी डिक्रीज. क्लियर आहे, एकदम क्रिस्टल क्लियर आहे, काहीच डाउट नाही. ठीक आहे. So see, the conclusion is now we see that internal energy of system can be changed in two different ways. First, by heating it. Second, by doing work on it. Work on it means surround system. So experiment we discussed just now can be carried out in very meticulous way so that we achieve the same change in the temperature of the gas by both the methods. Now it is our skill and our calculation, so that by both of the ways temperature will change by the same. Okay? Now conclusion of these experiments, these both experiments will lead us to very important principle of thermodynamics, and it is related to work done on the system or by the system. So if piston is pushed, work done on the system. If piston is pulled, work done by the system. आतमधल्यांनी बाहेर ढकलले up. So work is done on the system and by the system is important. On by ला खूप मोठा meaning आहे. And change in the internal energy of the system will totally depend on this on and by. So both are related through the energy that is transferred to system or transferred by system. ठीक है? Transferred to system from surrounding or transferred by system to surrounding. And the heat is involved in this process, so this will now lead us to the first law of thermodynamics. This is totally related with the काय पहिला आता internal energy, heat and work done. So these three concepts are in first law of thermodynamics. काही डाऊट आहे? स्टार्टिंगला स्लो होते, नंतर हळूहळू थिअरी आहे सगळं. फर्स्ट वन आहे कम्प्लीट होणार then स्टार्टिंग होणार. Start reading from start and write down the notes. त्याचे राहिले असेल तर ते पण. खूप लोड आहे. देऊ का? या लेक्चर मध्ये सगळ्यात जास्त इम्पॉर्टंट छोटे छोटे टॉपिक्स आहेत. येस, थर्मोडायनामिक सिस्टम, प्रोसेस, ओपन क्लोज, आयसोलेट. इट इज सो सिली बट स्टिल तुम्हाला एक्झाम्पल एवढं सिंपल नाही. You have to identify what type of a system it is. And this exchange temperature वर ते डिपेंड आहे and the change in the internal. ते एक्सप्लेन करायला बोलतात. Explain the different ways to change the internal energy of the system. Describe, explain with the help of the diagram. जिथं डायग्राम शिवाय तुम्हाला लिहिता येत नाही ना तिथं डायग्राम काढलीच पाहिजे. आणि जर डायग्राम नेसेसरी इन्स्टेड यू आर रायटिंग देन समवट तुम्ही एकतर ते लर्न करून रट्टा मारून आले असा मिनिंग निघतो. तसं पातेल्यामध्ये असेल तर व्हॉल्यूम ठीक आहे, व्हॉल्यूम सेम ठेवा बट पातेल्याचा अपर सरफेस इज क्वाइट ग्रेटर, मोठा आहे ना. सो तुमचे जे बबल्स और बॉईल होणार आहे ते जास्ती वरती नाही येणार. कळशीच्या केसमध्ये काय होतं, ओपनिंग इज क्वाइट स्मॉल. मग तो एवढा व्हॉल्यूम बॉईल होतोय तर तो समटाइम्स येत असेल, मी तर नाही पाहिलं पण येत पण असेल. बट दूध जेवढं वरती येतं ना हीट केल्यानंतर तेवढं पाणी नाही, कारण पटकन वेपोज आणि व्हॉल्यूम हळूहळू डिक्रीज होतो. Because water is changing into steam. Liquid changing.
ग्रेव्ही असते ना ग्रेव्ही,
हां.
त्याला आपण गार म्हणजे असं वरचं जे असतं ना ते काढून ठेवतो. त्यात आत लाईक होल टाईप बनतं, ते एअर मॉलिक्युल्स निघतात का बाहेर?
जे बबल्स क्रिएट होतात तसे?
नाही, म्हणजे बनून झालंय. इव्हन केक मध्ये बघा ना, केकचं बॅटर जेव्हा बनवतो ना आपण तेव्हा त्याचा बबल सारखा असतो.
तो वॉटर कंटेंट आहे मध्ये मध्ये राहिलेला, जो आपण मर्क्युरी बॅरोमीटर मध्ये बघितलेला आठवतं की ट्यूब टेस्ट ट्यूब सारखा आहे आणि आपण डिप करतो आणि व्हॅक्यूम क्रिएट होतं, टोरी सेरीज व्हॅक्यूम त्याच्यासारखा तो क्रिएट होतो. म्हणून केकचं बॅटर बनवताना बोलतात खूप जास्ती हे करायचं आणि येस आणि बबल्स आल्यावर ते टॅप करायचं. सो टॅप केल्यानंतर खालचे बबल्स वरती येतात आणि तो आतमध्ये क्रिएट झालेला स्पेस आहे तो नाही पाहिजे तर तो इट विल नॉट बी गुड. आणि ग्रेव्हीच्या केसमध्ये ना जेव्हा ते उडतं तेव्हा बाहेर सांडते ना ग्रेव्ही, बिकॉज तो जो वॉटर कंटेंट आहे ना त्याच्यासोबत तो सॉलिड पार्ट पण थोडा येतो, मग ते मोठे फुटतात ना म्हणून ते बाहेर पडतात. आणि किचन
हंड्रेड डिग्री सेल्सिअस
रीच ऑइलचा बॉइलिंग पॉइंट म्हणून दॅट इज ग्रेटर, वॉटरचा कमी आहे, 100 आहे ऑइलचा ग्रेटर. तर वॉटर टाकल्याने नाही शिजायला ठेवलं आणि तू चालू केलं तर इट गेट्स बॉईल इझिली, पटकन टेम्परेचर रीच नाही करत, लागून जातं. तसं ऑइलच्या केसमध्ये होतं. ऑइल कॅन रीच मच हायर टेम्परेचर. कधी तुला काही डाऊट आहे चिकन कशामध्ये वगैरे शिजेल? हा ग्लास मी म्यूट करू. जेवढं तुम्ही नॉर्मल मध्ये पण आईस क्यूब्स टाकत जाणार, इट विल ट्राय टू रीच द थर्मल इक्विलिब्रियम. Again you are adding, its volume will increase, it will get मधून काढलेली बॉटल गार पाण्याची, त्याच्यामध्ये बॉटल मधलं पाणी बाहेर नाही. बॉटलचा जो आउटर सरफेस आहे तिथे वेपर्स क्रिएट झालेले असतात. आतमध्ये कूल झालंय टेम्परेचर, नाउ इट इज इन द फॉर्म ऑफ द वेपर्स. या सरफेस वरती वेपर्स जे की खूप थंड आहे. हा सरफेस पूर्ण थंड झालेला आहे ना, सम अमाउंट ऑफ वॉटर कंटेंट विल बी देयर. हे जर तू काढून बाहेर ठेवलं तर दिस चिल्ड ज्याचं खूप टेम्परेचर लेस आहे ते आता नॉर्मल टेम्परेचरला येणार. नॉर्मल टेम्परेचरला येऊन नाऊ द स्टीम इज गेटिंग कन्वर्टेड इनटू द वॉटर फॉर्म, आणि तो वॉटर फॉर्म खाली येतो आणि तिथे पाणी पाणी होतं. आणि जसं तू बोलला गरमचं तर उलट होणार ना. Anything else? Ranveer? Save that.
सांगायचं तरी मॅम काढायचं.
सांगू का? 53 minutes only. Marks are